So last day we saw when we have a single object and with forces acting on it, it's going to accelerate. But now we're going to look at a more complicated types of questions, what we call systems, when we have two objects interacting with each other. So for this one we have a 15 kilogram block and a 10 kilogram block and a 40 Newton force pushing to the left. And in the real world, like in physics, we look at simple cases. First we look at one block, then two blocks, and then we'll look at three blocks acting together. In the real world, things are complicated. Just imagine your human body, all these different individual bones connected to each other, and they're all influencing one another. So in this case, let's make sure we understand the basics. So here we go. So we have a 15 kilogram block, 10 kilogram block, and a 40 Newton force. So first part of the question, what is the acceleration of each box? So because they're touching each other and the force is being applied from the right, they're going to accelerate together. So for question A, we can first think of this as acting as instead of thinking of it as two separate boxes, we can think of it as a single 25.0 kilogram box. And let's draw the forces acting on this box. We have 40 newtons acting, the applied force acting to the left. And there is also a force of gravity acting downwards and force normal acting upwards. We don't actually need force of gravity and force normal in this case because that's only usually necessary if there is friction. If there was friction, friction would oppose the direction of motion and it would be in this direction as shown. So let's see what our acceleration is. So acceleration, sum of the forces in the x direction. I'm going to define left as positive to make my life a bit easier. So I'm going to say left is positive and up is positive. So force of friction, sum of the forces is equal to mass times acceleration in the x direction. And what forces are causing this acceleration? We have Fa is pushing to the left, and we have force of friction opposing that. Again, in this case, we're ignoring friction, so that is just going to equal to 0. So we end up with our mass is 25.0 kilograms multiplied by AX is equal to 40.0 newtons. So we find out our acceleration is just 40 divided by 25, we get 1.60 meters per second squared. Now question B is asking what is the contact force exerted by each box onto the other. So this is Newton's third law. What we need to recognize is that the 10 kilogram block is pushing on the 15 kilogram block. But there's going to be an opposite and equal reactions. The 15 kilogram block is pushing back onto the 10 kilogram block. So if I think of this as box 1 and this is box 2, I can think of it as the contact force. This is 1 acting on 2. This other one's force of 2 acting on 1. So how we're going to solve for this, when we're solving for this contact force, we either need to look at just the 15 kilogram block or the 10 kilogram block. Before we move on to that too, let's look at what happens if we looked at the previous question, again including all of the forces. So we had a 40 Newton force acting to the left, and I said there was that force of gravity, force normal, force of gravity, force normal, but there are also these contact force, FC. So in the first part, what we actually did, we looked at what we call the whole system. So we look at the whole system, we saw that the sum of the forces in the x direction is mass times acceleration in the x direction. That equal to force applied minus force of friction but there's also that contact force. But notice how one of the contact forces is pointing to the left. The other contact force is pointing to the right. So they actually just cancel out when we look at the whole system. So if we look at the whole system, we can't actually solve for those individual forces. So what we need to do is we need to look at each block individually if we want to solve for the contact force. And it doesn't matter which one we look at. So if we look at the 10 kilogram block, here's my 10 kilogram block, 10.0 kilograms. Let's draw the forces acting on that 10 kilogram. We'll do the 15 kilogram block at the same time. Here's my 15.0 kilogram block. So look at the 10 kilogram block. We say, okay, that 40 newtons is pushing to the left, 40.0 newtons. But we also said that we have that contact force pushing back. So let's call it FC, that contact force. So we get an equation. We get sum of the forces. Yes, there is the normal force and force of gravity, but we know they're not really playing a part in this question, so I'm just going to ignore it for now. So sum of the forces is equal to mass times acceleration. This is mass of block 1. And that is equal to, we have the 40 newtons pushing to the left. You know, you said left is positive for this question. And it's being opposed by that contact force. So in this one, we're looking at this, the 15 kilogram block doesn't even exist right now. We're just looking at just the 10 kilogram block. So our mass is 10.0 kilograms. We just solved for our acceleration. So we know if the system is moving at 1.6 meters per second squared, we know each individual object is also moving at 1.6 meters per second squared. So 40.0 newtons minus FC. So we solve for FC, we get 40 minus 10 times 1.6. So we get 24 newtons. If we look at a 15 kilogram block, say, okay, the 40 Newton force, it's not actually pushing on directly on the 15 kilogram block. What's making this thing accelerate is just that contact force. Block 1 pushing on block 2, so FC. So for this one, we have sum of the forces is equal to our mass 2 times acceleration. And the only force acting on this is force C. So the mass is 15.0 kilograms. Our acceleration is 1.60 meters per second squared. And that's equal to our contact force. And lo and behold, when we multiply 15 times 1.6, you get the exact same value of 24.0 newtons. And that's because Newton's third law states for every action there must be an equal and opposite reaction. So both blocks exert a contact force on the other block. Same magnitude, but opposite direction.